All right, guys, let's get started. So welcome to lecture 4 of the Battlecode lecture series. Today we're going to be doing some bot improvements and communication. So to get started, the code we have here is just a copy of the example funcs player. So you've already seen this. We went over this yesterday. Let's just run one game with what we currently have just to see kind of what it looks like. You guys might have seen this before, but in the current state of example funcs player, it's not really great. Both teams kind of don't really know what they're doing, and also the silver team especially just kind of does nothing. So we can kind of figure out what's going on here. If we look at the start of the game, the silver team is spawning some soldiers who are supposed to be filling in their tiles. So they look for a ruin. If we go to the code here, we can see they sense nearby map infos and they find a ruin to go to. But if we watch what happens, once they see another ruin in their radius, they start pathfinding up towards like random ruins. And that's just because of the way we pass in map infos to this method. So just whatever the first ruin we find is in this array, or sorry, I guess the last one we find in this array, depends on like dictates where we actually go. So the first thing we can do, maybe make this a little bit better, is rather than just finding arbitrary ruin to move to, let's make it so we find the closest ruin. So we can just set current distance equals some large number. And then we'll say if tile has ruin, we'll get the distance. So distance equals, we can say tile dot get application distance squared 2. And this will get us our distance squared to the current player from the tile. Basically, we'll just say if dist is less than per dist, then we want to set the ruin and per dist equals dist. So all this is basically doing is just moving us to the closest ruin rather than just some arbitrary ruin. So now if we run this code, let's just see what happens. So you can immediately see a lot more is going on here. The bots are actually much smarter. We're actually filling in tiles in our side. Also for context, we're running silver will be our player, and then gold will be example funcs player for this lecture. So yeah, already much better. But one major issue here is we built this one tower here, but like no other towers ever get built. And that's pretty bad. If we go look at the game tab, we can kind of see why the chips never reach 1,000, and it takes 1,000 chips to build the tower. So we're basically just never have enough chips to build any towers. So how can we, improve this? One idea is, so the main issue is that our tower just every turn it runs, it just tries to build a robot. And obviously if we're doing that for all of our towers, there's no way we're ever going to reach 1,000 chips because each robot costs 200 to 400 chips to make. So we can think of using communication in order to kind of help mitigate this problem. And this is not, a perfect strategy, but it's kind of a good example of how you could use communication in a way that lets you send information between your robots. So let's start by thinking about what kind of messages we want to send. So the idea here basically is, we have these ruins which are ready to be built on. So we have the pattern fully completed, but we have no way of saving enough money. How can we basically check when this is happening and tell our towers to stop producing robots for like some amount of turns? And then this way we can make it so we can save up enough chips and then actually build towers. So one thing we could possibly do is set up some sort of messenger system. So let's just say since our moppers kind of don't really do anything in this player, they kind of just walk around. Our soldiers have a more important function. They actually draw the paint and stuff. Let's just say the moppers are our messengers. What we can do is we can define some moppers that we spawn in to be messengers. So let's just make a variable in our class just called static boolean is messenger equals false. And that'll start off by false, but we can assign some of our moppers to be messengers when they spawn in. So one way you can do this is in your run method, before your while loop, you can actually run some code in here. So we can say if rc.getType equals unit type dot mopper. And one trick we can do to kind of make it so not all the moppers are messengers, we can say, and rc.getID mod2 equals 0. So this is basically just on average assign half of our moppers to be messengers. We can say is messenger equals true. So these variables that we have are static, but they only are local to each robot. So each robot has their own copy of all these variables. We can kind of are free to do whatever we want in these variables. So that's why we can do this. Let's just visualize this quickly. So in our run mopper method, let's just check if is messenger. Let's just set an indicator dot on our current location so we can see what that looks like on the map. Say rc.set indicator dot get location. We'll just make it red. So now if we run this code, we should see that some of our moppers have dots on them. So if I stop this early, we can see that our moppers do have dots on them, and these indicate that they're messengers, so that we know that this is working. Okay, so now that we have some robots who we've dedicated to be messengers, how do we actually send messages to communicate what we want? So the goal here is to communicate that we should to our towers that we want them to stop producing robots for some amount of turns. What we can do basically is let's just set up some heuristics. So we'll say if we see a ruin that has some markers around it, let's assume that we're trying to build a tower on it. Seems pretty reasonable. If that's the case, we should go back to our tower and tell it, hey, you should stop producing robots for some amount of time so we can save up for our tower. So there's a lot of steps kind of in there, but let's just kind of approach this one step at a time. So the first thing you probably want to do is store the tower locations in our messengers. So our messengers need to know what towers to go back to. And we can do that sort of by storing those locally. So let's make another variable called static, and we'll make an array list of map locations. And we'll call them known towers equals new array list. We'll initialize that up there. And then in our moppers, we need some way to store these locations. So we have this method that already exists called update enemy robots, which, if you guys remember from the example functions player, basically just looks for nearby enemies and then puts them in an array and kind of broadcasts messages. We can do something similar, but for friendly towers. So we can look for nearby friendly towers and then store them in our towers array if they don't already exist. So let's do that quickly. So we can say robot info array ally robots equals rc.sense nearby robots. And then we want to make sure that we do -1 for the maximum radius and then rc.get team because we want to search for our team. Then we can say for robot info ally robots. So we're just looping over all our allies. So we care about the towers. So if it's not a tower, ally.get type that is tower type. If it's not a tower type, then we should continue. And then now we need to check if our tower is already in our list of towers that we're sort of storing. So we'll say if known towers dot contains let's make a new variable here actually, map location ally location equals ally dot location. So if our tower contains the ally location, then skip this one. We'll come back to this later, but for now, to do what to do with known towers. For now, we'll just skip it. So we have our array of towers. So if it is a tower and we don't already have it in our tower array, let's just add it to our tower array. So known towers dot add ally location. So that should basically just make sure that for each mopper that's messenger, we store all the towers that we've seen so far, basically. So let's actually call this method. So if we are a messenger, so this is our mopper function. If we're a messenger, we'll just say update friendly towers RC. So this should basically put all our towers that we've seen into this array. While we're at it, let's quickly, before I forget, turn off this old messaging system that we had, just because we'll be needing to override that later. Okay, so, all right, so that's kind of part one of our messenger type. So now that we have this list of towers, we need to figure out our condition for when we want to actually return to our towers. So like we were saying earlier, if we see like an unfinished ruin, we want to rush back to our tower and let it know that we want to build a ruin or a tower. So we can kind of use a heuristic for this. There's no easy way to check if like the pattern is already completed or anything like that, without checking if the ruin has a tower on it. So a heuristic we can kind of use is, why don't we just say, okay, if we see a ruin and there's no tower on it, and we see a friendly marker nearby, then we'll just assume that we're trying to build a tower on that ruin right now. So we can, let's implement this quickly. So we have this check nearby ruins function. We can kind of just copy a bunch of the stuff from our soldier method. Let's put that in here. So we're setting nearby infos, map infos, and then we're checking for basically any ruin. We don't care what ruin it is, so we don't need to actually store this. So loop over all the tiles. If tile has ruin, and we want to make sure that the tower is not completed yet, since tiles that have towers still, this has ruin will still be true. So make sure you check both. So basically the way we can do that is we can say if the tile has a ruin and rc dot get robot or sense robot at location tile dot get location is equal to null. This basically what this is doing is it's checking, okay, the tile does have a ruin and the robot at the tile's location is null, so there's no tower on it. If that's true, then we know that this is something, a condition that we care about for our mopper. So we want to like set some condition in our messenger that indicates that we want to be returning back to our tower. So we can just store another variable for this, since these are all independent for each robot. We can just say static boolean is saving equals false. And we know if is saving is true, this means that we've seen a ruin and we want to start saving for a tower. So let's set that in here. We'll say is saving equals true. And then we can just return because we don't do anything else in this function. Oh yes, one other thing that I forgot. We also want to check if there's a marker nearby. Because we care if it's a friendly ruin. So we can do that. Let's import this function. Let's say if not tile has ruin, then continue. And then if not, or if RC sense robot location is equal to null, or not equal to null, if there is a tower there, then we'll also continue. And then we want to make sure that there's a friendly marker nearby. So the way we can do that is since our robot is going to be positioned somewhere relative to the ruin, we can just get the closest tile between us and the ruin, or like in the direction between us and the ruin. So the way we can do that is we can say tile dot get map location dot direction to, and then our current location. That kind of guarantees us that there's probably some tile in between where we are and then where the ruin is. And then let's just say that direction there equals that. And then to get the tile that's actually like one away from the ruin, we can say tile.get application dot add. So we'll say this is like application mark tile. What's that? That should be like the tile one around where the ruin is. So now we can say if mark tile dot or sorry, we need to sense map info. So let's say RC sense map info, and then we pass in the mark location, and then get the mark, and then is ally. So if that's not true, we want to continue. And then we can do this condition here. So does this make sense, what we've done so far in this function? Everyone understand? Okay, cool. So yeah, so now we're just using this heuristic to see if we need to start saving. Okay, now that we've decided this, oh, actually, let's call this function too. check by ruins. Okay, so now that we've actually like set this flag, let's do the next step, which is we need to go back to the towers and send messages to them. So what we can do is in our movement code for our mopper, we basically want to say, so right now we're just moving randomly. So we have this, if RC, we pick a random direction, and then if RC can move, we just move in that direction. Let's do something special if we're a messenger. So we'll say if is messenger and we're currently saving, this means we want to rush back to our tower. So let's set like a application destination equals known towers 0. So you could probably do a smarter way of doing this. Oops. What's more this we can do? There's definitely smarter ways of doing this. This is probably as simple as it's going to get, but that's an exercise for you guys. For the sake of this, we'll just pick the first tower that we've seen and go back to it. And then just make sure we can say, and known towers dot length or size greater than 0. Then we do that. Why is this mad? Okay. Okay, so we have our destination. Let's move towards that. So we can say same thing we just did before. We can say RC get location dot direction to, and then the destination. And then that's our direction. And then we check if RC dot can move in that direction, then RC move in that direction. And the good thing about the way we structured this code is even if none of these things are true, or even if we get into this block and this doesn't pass, we'll still do this. So if we've already moved, then this will just be false and won't happen. But if we haven't, then this guarantees that our bot will always be moving around in some way. So let's just run this right now and see what happens. So we should, in theory, have some strange behavior. Might be hard to track. Let me just stop this early. Well, let's see if we can see what our mopper is doing. So this mopper is going around. Let's see if it sees the ruin. I think it's staying nearby the towers because it keeps seeing the same ruin. So yeah, let's just keep implementing. It might be kind of hard to see what's going on right now. So the next thing we need to do is, so we have it so the moppers will in theory move back towards its original tower. So now we need to actually tell the tower to start saving. So what we can do is in our friendly towers method, right now, if we see a tower that's friendly and we've already seen it before, we just skip. But instead of that, why don't we, if we've seen a known tower, let's just send it a message rather than skipping it. So basically, if known towers contains our ally location, then if we're currently saving, which means that we're trying to go back and send a message to a tower, we'll do something here, and then we'll skip. So even if we're not saving, we still skip adding it to the tower list. Okay, so is saving. If we are saving, let's send a message to the tower. To do this, we can just say rc dot if rc dot can send message, and then we pass it in location. So location of our tower. Then we want to send it a message, rc dot send message, and then ally location. And now we need an actual message. So how are we going to, structure our messages here? There's a bunch of different ways you can probably approach this. You can either pack some bits into an int or anything you can possibly think of into an int. But for this, what we'll do is we'll just make an enum, and the enum values represent different kinds of messages that we can send. So up at the top here, let's just say private enum message type. And then for now, we'll have one message, and then we'll call it save chips. And this way we can send and receive messages between our bots, and we have a unified way of like decoding what the message actually is. So let's send that message here. So we'll say message type dot save chips, and then dot ordinal just takes the enum and turns it into an integer. So in this case, save chips will be 0 because it's the first value in our enum. So yeah, that's basically all we need to do here. We should probably also, once we send a message, turn off our flag because we've already sent our message. So once we've sent it, we should probably say is saving equals false. That way we're back to our original state, I guess. And then, so yeah, so that's that setup. Let's see if we can see this now. It might still be hard to see, but in theory, the robots should stop sending messages and then go back to their default behavior. Let's see if they actually do that. This mopper. It's going along. Yeah, see, I think on this map it's kind of hard to see because the rooms are so close together. So let's just keep going. Okay, now we've sent the message. Now we need to actually receive the message with our towers. So right now what we're doing, if we go to our tower code, is it's up here. We're basically just reading all our current messages. So read messages just takes in everything from the queue, and then we're just printing them out, which is fine. But let's actually do some more logic in here. So now we know what kind of messages we could possibly receive. Let's check that. So we'll say if m.get bytes. So this is like the content of the message is just an integer. If we look at the return type here, if that is equal to, and then we'll say message type dot save chips dot ordinal. We know we received a saved message. So let's do something with that. So how do we store state in our tower to like make sure that we don't build any bots? I think we should just make another variable. So let's just do that. Let's say static int saving turns equals 0. This will only be used in our towers, and we'll set this when we want to tell our tower to save for a certain amount of turns. So let's go back to our tower code. Okay, so right now in our tower code, we're just building a robot every turn if we can. So let's change that. Why don't we say if saving turns equal to 0. So when we're not trying to save, then we'll build a robot. Otherwise, let's subtract saving turns. So saving turns minus minus. So basically this means that the tower will not build any bots for n turns. And let's also make a debug tool for us. We can say rc set indicator string, and then we'll call this saving for, let's put this up here, saving for, and then saving turns, and then more turns. Okay, now we can see on our tower how many turns it's saving for. And let's set this here. Let's just pick a random number for now. Just say saving turns equals 10 or something. Let's run that and let's see what it looks like. So now in theory, once our moppers see a ruin, they should go back to the tower and then tell it to start saving. So already you can see we did build 2 more towers just from that, which is pretty interesting. But let's just look at this behavior just to verify. So we can see the tower currently says saving for 10 more turns. And as long as this mopper is like nearby, because this mopper is in range of this ruin and this tower at the same time. So it's just kind of like permanently stuck saving, which is probably not great. So what we can do is let's fix that. Let's basically say, so right now we're just using this is saving flag for our mopper. Let's also use it in our tower. So we can say if we receive the save chips message and we're currently not saving, then we set our saving turns to be something. And then is saving equals true. And then once we get in here, we can set is saving equals false. Now it basically means that the tower will tick down its saving status. And then hopefully we'll build things more often than not that often. Let's see what it does. Okay. So we can see there's a lot more robots on the board this time, for sure. Our side has a lot more bots, which is good. Because we definitely don't want to trade off between building towers and building bots. If you build too many towers and never build robots, you're going to get overwhelmed. So we can definitely tune this number as well, because right now it's just 10. It's kind of random. Let's just try increasing it to 30. And we can look at our graphs and see kind of what they look like. So we can see these spikes in silver chips. This is like our towers saving up and then spending them on towers, but it only happens a couple times. Let's try increasing the number of turns that we save for up to 30. Let's run this and see what happens. Okay, so we built another tower this time. Let's check at what this looks like at the end of the game. So yeah, we can see a bunch more of these like 1,000 chip spikes. And now we've not only filled up more of the map, but also built more towers, which is pretty good. So now we have 4 versus 3. Let's try this again on some of the other maps. Let's look at it on medium. See what that looks like. So already we can see 3 towers built versus 2. Here's let's see what that looks like at the end. Yeah, so we see the spikes here. We can see, okay, we only have 1 extra tower than gold, but our map coverage is way better, which is pretty good. Let's try it on large, see how it looks. So you definitely notice one failure mode with this method, this naive method of just going back to the first tower you found, is that if you get these like isolated towers in the corner, it'll be hard for moppers to kind of go to their initial spots. And to go from their initial location to find a ruin, and then like it's just too spread out. So this technique definitely works better on bigger maps. But you can still see there's definitely some improvement in terms of like coverage and whatnot. But it looks like we're still not quite reaching our 1,000 chips. Let's try increasing this even more to 50 turns. Let's try this on large again. So here we go. So now we can see we're building some more towers now. And so yeah, so you can definitely improve this method. So now we have 2 versus 4 towers, which is pretty good. And you know, the number of moppers that you assign to be messengers, all these, there's a lot of number of variables here that you can mess with. But that's kind of the basic idea for this communication method. Communication this year is definitely tricky. We'll probably make some minor modifications to it after the first sprint. But for now, you're stuck with sending messages from robots to towers or from towers to robots. So in this lecture, we didn't really go over any way to set any like good strategy for sending messages from towers to robots. But it's something that you can use to your advantage. Markers are also another way of doing indirect communication. So, you know, in this example, we looked at markers around the ruins to see whether or not we're trying to build a tower. That's kind of a way we use those as an indirect way of communicating between our bots. You can come up with other clever strategies similar to that if you wanted to. But yeah, so that's basically all that I have for a code, this basic example. We'll be posting this updated code in like a new repo on our GitHub page so you guys can follow along with the lecture bots online and use them for yourself. But yeah, any questions about the bot or communication or anything? Cool. Well, yeah, well, we'll be here for the next while. So if you have any questions about this or just anything, please come up. We have food in the back. But yeah, thank you guys for coming.